I'm going to go ahead and show you that other method one more time. We will use it a couple different times on some different problems, so I do want to mention it to you. So the first method I said would be that we're going to find the highest degree, and we're going to divide each term by that highest degree. So the highest degree is this x squared. So what I'm going to do is I'm going to divide every term by that x squared. So I've got 2x squared over x squared minus x over x squared plus 3 over x squared all over 3x squared over x squared plus 5 over x squared. So now I have the limit as x approaches infinity of 2 minus 1 over x plus 3 over x squared all over 3 plus 5 over x squared. And all I did was simplify each one of those. The last part of this is to think about what is the limit of each of these separate terms, because we can take the limit of each one separately. So the limit as x approaches infinity of 2 is 2. The limit as x approaches infinity of 1 over x would be, this number is getting really, really, really big. 1 divided by a really big number is actually approaching 0. Again, 3 over a really, really, really big number, so it's approaching 0. 3 divided by a really big number approaches 0. Down here, the limit as x approaches infinity of 3 is 3, plus the limit as x approaches 5 over this really big number. 5 divided by a really big number would approach 0. So that means that my limit is 2/3. That would mean that my horizontal asymptote equation would be y equals 2/3. Now, let's talk about that L'Hopital's rule, and I'll do that in red. L'Hopital's rule makes everything way easier, and you'll see how much it really is. All you do is you pick the highest degree on top and the highest degree on the bottom. You simplify, and done. I think you would all agree that that is much simpler. It is a rule. These problems, I will be happy to talk about how they match up during class. If you guys will bring that up during class, we can talk about those. Right now, I'm not going to go through each of those matching. I'll just do some more examples. So another way that we can find limits versus infinity is by using a graphing calculator. In this problem, if I go ahead and just use L'Hopital's rule and pick the highest degree on the top, which would be the 4x, and the highest degree on the bottom, which is the 2x, and I simplify, I get my answer to be 2. I don't really need to use the graphing calculator to do this. But go ahead and practice. Use your table on your graphing calculator. Punch this in for your y equals equation. And then use the table and ask it these types of questions. 10 to the 0 power is really a 1. So if I was to put 1 in here, I can do that in my head. I'd end up getting 7 on top and 1 on the bottom, which would give me a 7. But the rest of these, if you just use that table function, you can pause this video and do that. Use the table function, put this in for your y equals, and then hit the table button, and then ask it all of these questions. 10 to the first, 10 to the second, 10 to the 10 to the third, 10 to the fourth. This is going to infinity. See what number it approaches. I'll write down the answers for this. And as you see, these numbers, as I get further and further out, they're getting closer and closer to 2. And I'll finally just write 2. And 2 is the answer. Moving on to some other examples here. To find as x approaches infinity, if possible. So on these examples, I'm going to go ahead and substitute what f of x is. So h of x is equal to 5x squared minus 3x plus 7 all over x. The limit, use L'Hopital's rule. Take the highest degree on top and the highest degree on the bottom. Simplify. You get 5x. Well, as you approach infinity, that would go to infinity. We'll continue this in the next video.